What if, in mathematics, proof isn't about truth? What if it's more like agreement, a kind of ritual we perform not to uncover some eternal fact, but to reach consensus within a certain system using rules we've all agreed to follow? It sounds strange at first, especially if you've always thought of math as the most objective, precise thing we have. But the more you look at how proof actually works, the more that distinction between truth and agreement starts to blur. Think about what a proof really is. It's a series of statements, each justified by previous ones, based on certain axioms and definitions. But it's not finished until someone else, often a teacher, a professor, a peer, or a journal reviewer, says, yes, that makes sense. So, in that way, it's a kind of social act, isn't it? A performance with rules, something we submit for approval, not just construct in isolation. That doesn't make it meaningless though, but it does make it dependent, not just on logic, but on people. This isn't just theoretical, by the way. Throughout history, what counts as a valid proof has changed multiple times. What once passed as rigorous might now seem sloppy or just plain wrong. Aimé Lakatos, a philosopher of mathematics, described this beautifully. Proofs evolve. They get revised, sometimes they get abandoned altogether. That means a proof is only as strong as the standards of the time, and those standards are constantly in motion. So even when a proof feels airtight, it's still operating in a kind of social and historical context. Nowhere is that clearer than when we look at axioms. Axioms aren't proven, they're assumed. They're the foundation we choose to build on voluntarily. And once you realize that, you start to see how radically different mathematics can become just by tweaking the base a little bit. Take Euclid's fifth postulate, the one about parallel lines. For centuries, it was just taken as obvious. But when mathematicians later started to question it, they ended up with non-Euclidean geometry where parallel lines don't exist at all. And the result? A totally different geometry. Still rigorous, still provable, just running on different assumptions. Then there's intuitionism, the school of thought led by L.E.J. Brouwer. In that framework, the law of the excluded middle, the idea that every statement is either true or false, is rejected. So if you try to prove something by eliminating all other options, that's not enough. That's not considered a proof according to intuitionism. So now we're not just changing the assumptions, we're changing the rules for what even counts as a valid argument. And again, it works. Why not? Intuitionist math is consistent, but it produces different results. So, is one version true or more true, whatever that means? Or are they just internally coherent systems with different rules? This is where the conversation brushes up against Platonism, the idea that math exists in some eternal, abstract realm and that proofs are glimpses into it. That might be comforting, I guess, but it's hard to square with the fact that different logical systems built on different axioms can all produce valid, even beautiful mathematics. If we can prove contradictory things depending on the system, what exactly are we even proving then? Imagine applying that to real life. Suppose someone's on trial for murder. You wouldn't say, well, in this legal framework, we proved he's guilty, but in this other one, we proved he's innocent, so they're both valid. No, we expect the outcome to track with something objective, something that actually happened. Either the person did it or they didn't. We don't say, well, it depends on which framework you prefer. But that's kind of what mathematics allows, which is fine until we forget that distinction and start treating mathematical proof like it reveals some universal metaphysical truth. And sure, sometimes it does, but sometimes it just shows that the system holds together. In truth, proof is only as strong as the system behind it and the people who agreed to follow its rules. Maybe proof isn't synonymous with truth. Maybe it's a kind of structured persuasion, a shared logic game we've collectively agreed to take seriously. That doesn't make it less beautiful, but it does make it more human. Even David Hilbert, one of the giants of modern mathematics, leaned into this with formalism, the idea that math is ultimately about manipulating symbols according to rules. It's not about meaning or truth in some cosmic sense, just the consistency of the system. And sometimes, it's worth remembering that even in mathematics, truth and agreement aren't always the same thing.